Alright, so last time, this is where we left off. So let me open up the old Epic Pen. So last time we were right here, and we were basically just talking about, after we had done these two questions before, we were talking about the primary kinematic coefficients, right? So this is the H's that we found in the previous chapter. And so we're going to read a little bit here, and then we're going to get back to some examples. So let me scroll down the page a little bit. All right, cool. So it says, since the primary kinematic coefficients are velocity ratios and only depend on the geometry of the mechanism, they must be related to the distances between the instant centers. Indeed, that is the case, as will be shown in this section. Instant center method of finding kinematic coefficients is quick and efficient. So this is kind of what I said the other day, is that the long equations, the deriving and all that, that is a long way of doing it, but it could net you a better answer, a more accurate answer, depending on how you measure everything. So anyway, and then it says, consider the slider crank in example 2, which is the one we looked at just before, with instant center shown in figure 10b right here. In the figure, we consider the velocities of 2 points on link 2. Point A is located at I23, which is right here. And A2 is at a point at A belonging to link 2. And similarly, point B is located at I24, and B2 is a point at B belonging to link 2. We can write the magnitude of velocities of point A2 and B2 using the angular velocity of link 2 and distances from the center of the ground pin about which link 2 rotates. Therefore, right here it says, alright, so VA2, so the velocity at point A2 is I12 and I23. So I12 and I23, that distance right here, times W2. And VB2 is I12 here, and to I24, which is over here, times omega 2. Where I12 and I23 is the distance from instant center I12 to instant center I23. Since point A is located at I23, the velocity of a point at A attached to link 2 must be equal to the velocity of a point A attached to link 3, A3. Otherwise, there will be a relative velocity between links 2 and 3 at I23, which cannot be allowed because that is where they are connected. Using the saying argument, the velocity of a point at B attached to link 4, B4, must be equal to the velocity of B2 since they're both located at I24. Thus, you can write VA3 equals VA2 and VB4 equals VB2. And then it says, note that link 3 is rotating about I13 at the instant shown in figure 11, which is this one right here. The velocity of point A3 can be written in terms of the angular velocity of link 3. So VA3 is equal to I13, I23, omega 3. And then it says, in light of equations 7, 6, and 8 yield the following, or in light of equation 7, 6 and 8 yield the following result, which 6 and 8, so 8 is this one, 6 is this one. You get I13, I23, omega 3 is equal to I12, I23, omega 2, which that is because we did these equations up here. And if you substitute these things in, so like if you maneuver it around and you move this to the other side and divide by this, you get H3. Remember, H3 is equal to omega 3 over omega 2 from the original definition of H in the previous chapter, which was the velocity ratio, right? And since we did all this, derivation up here, when you put these together, you end up finding that H3 can be represented as I12, I23 over, or this, H3 can be represented by these two quantities divided by this one. So I12, I23 divided by I13, I23. But I know the derivation might, kind of bore you, but essentially this equation is just I12, I2n over I1 in, I2 in. And n is whatever link you're on. So for example, we looked for link or H3, so you would put a 3 for all the n's. That's the equation for links. I think it's just the angular velocity of. There's like another type of case that we'll go through in a second where this equation does change, but I think this is the basic equation for angular velocity of a link, or velocity ratio of a link. Alright, and then it says, note that link 4 undergoes translation, which is this link, the block. So that member is going to be a different one. This one's going to be an F. So at every point on link 4 has the same velocity. Therefore, point B4 has the same velocity as the slider 4. We find from equations 6 and 7, so VB4 is equal to I12, I24, W2. But then it goes, as we maneuver this around, you get F4 is equal to VB4, omega 2 is equal to I12, I24. And so right here, these are your equations that I was just talking about. So right here, I put, they put I, I can just zoom in a little bit, but they put I for the input, but our input is generally 2, so I just put 2 there. But this is the base equation, is that I is the input, J is the link that you're finding it for. So this would be your 3, this would be your 2. But if the input link ever changes, you have to change it for that. And then we just did F, so this is for translations, Fi, or Fj, is I1I, Ij, man. Anyway. So in our case up here, this would be F4 is equal to I1, 2, I14. So, which would be this case we looked at right here. Alright, and then it says, next we consider a mechanism with translating input containing both rotary and translating links, which is that one. The instance centers of the mechanism has been located, and the process is summarized in the circle diagram for the mechanism. Note that point A is chosen, coincident I23, and B coincident with I34. The velocity of point A attached to link 2 is the input velocity and must be equal to the velocity of point A attached to link 3, since both are located at the same center. Yeah, we got it. Where there cannot be relative velocity between the links. So this one has a different sort of derivation because of how the problem is, and they just showed you how to find all the instance centers here. But omega 3, which, where did we get that at? So H3, omega 3 over VA2. VA2 is here. Oh, okay, it's because this is a little bit different how we're moving here. But let me see. So it says, using a similar argument for point B, we can claim that the velocity of B3 and B4 must be equal as dictated by the same instance center. Therefore, we may write VB4, VB3 is equal to I13, I34, omega 3. And if you combine equations 12 and 13, this is 13, 12 was written up here. You find that F4, which is the primary kinematic coefficient for the translation, is VB4 over VA2, so it's the velocity of A2 over the velocity of B4, I13, I34, I13, I23. And then, but once again, this is something that doesn't really, the derivation doesn't matter for you guys much because all of these equations are summarized, and they're summarized on a sheet that you will have for the exam and for your homework, so it's not too big deal. But this is the difference one I was talking about, is that here it says where I is the input link number and J is the output link number and M is the number for any rotating link in the mechanism. So what that means is this one actually has different ones. So it's 1 M and then you have J. So M you have to identify as the rotating link in the mechanism, which for ours is 3. Because as you can see on this one, these aren't rotating, but link 3 is. So it'd be I13, I3, I would say I3 what, 4? Is that what it is? Yeah, I3, 4. And then I13, I23. So, but yeah, these equations you'll have in their generic form, so you can fill those in, I'm sure. See what this one looks like. Eh, that's not fun. Trying to see which one we want to do. Has a problem today. Not on this one either. We're gonna go find another one. Because that is not what we're looking for. We're looking for a better example. Oh man, that one sucks. Oh wow, these are all kind of bad. Let's try this one. So this one right here. So this one might seem like really bad and everyone's like, ah man, I don't want to do this. But it isn't really that bad. You just have to follow the very simple rules that we have for solving these questions, right? So let me go ahead and open up this. So we're going to do the first thing, and the first thing is to do what, if anybody recalls? What shape do I have to draw? So I'm going to go ahead and do this. I'm going to go and put you some steps over here. So step 1, circle diagram. So our circle diagram will go right here. I'm going to try my best to make it fairly big. And how many links do we have in this question? So we could fill out that properly. We have, looks like 6, so 1, 2, 3, 4, 5, 6. So we must do that. So I'm going to put 1 here, 1 here. All right, so 1, 2, 3, 4, 5, and 6. So this is our circle diagram for this question. And now we need to go through and find all the instance centers that we know at the very start. So I'm going to use black for this one. So instance centers we know at the very start. And what that means is that essentially these are the ones that the locations are like pinned, you know, like the revolute joints and all that. So let's start with I12. Where would we find I12 at? Remember, this big yellow thing is 1. It's all 1. So, and 2 is this piece right here, this whole thing. So where would we find I12 at? We'd find it right here, right? Because this is the connection between 2 and 1. So right here, that's not going to work well. Maybe I should use dots here. Nope, too big. Let's try that. That's better. So that right there is I12. I'll probably get rid of these long arrows eventually, but now, similarly, we can find the next one. So I'll go ahead and fill this one in. I12. I23 would be located where? It would be located right here, because this is the connection between this piece, which is link 2, with this piece, which is link 3. So similarly, do the same thing. So I 2, 3. And then you connect that line down. So far, so good, I hope. All right, and now, what's another one we can find? So let's try I34. So where is the connection of link 3 and link 4? It is right here at this revolute, because this blue is intersecting with this one right here there. So that is I34. I'll get down a size there. So I34 goes there. So I34. What about I45? Also in this spot, right? Because we have link 5 here and link 4 here, and they're connecting on that same revolute point. So this is also I45. So I'm actually going to get rid of these for now. It's becoming too much. So let's draw that over here. I45, right? Alright, so now we have all of these outside ones going. Now we need to connect the next one, which is I56, right? I56 is this right here. Because that is the connection between this green block, which is the 6th link, and this right here, this link, which is 5, right? So go ahead and connect that one. We have that one pretty well done. Now, what about 6-1? Anybody want to take a shot at this one? 6-1? So this right here is pretty clearly a slider, right? I think everybody can, this thing slides up and down inside of this channel. This thing's pretty clearly a slider. So what does that mean, right? So we would have to go to our rules, which I have open somewhere in here. So right here is a slider, right? Which means we have I12 plus or minus infinity inside of the sliding translation. So using that thought, we would then write I12 as a line straight across here at plus or minus infinity. And this is I61. Does everybody see how we got all of these so far? I'm getting a record level of input today. No gifts either. So, all of these fairly straightforward, right? We filled out the outside. We just went to all the connections where they touch, you know, all of the revolutes, all of that. Basically, they were all revolutes. So, no big deal there. Now, we're going to have to get into the parts where we don't know. Right? And so I'm going to try and use different colors for each one. I'm going to get rid of this line, though, for now. Because it'll kind of get messy, I'm sure. So, let's go ahead and let's move into the next one. So, let's try, so what would you guys like to try? And remember, how we find these is you use triangles. So if we were trying to find I13, for example, which would be here, you would have to find two triangles that share that vertice, if that's the right term. I think it is. That same side. Is someone going to say we're missing one? Because we are, by the way. There is one other one that we know. What's another one that we know that I might have skipped over? And not might have, I did. I forgot about it completely. But that's okay. Which one did I skip over? 4-1, correct. So 4-1 is right here. It is this connection right there. I forgot about it. It is this yellow block connecting with that red loop. So my fault. All right. So now back to what I was doing before. So as I said, we need to find, if we're going to start with I13, which let's start with it. Let's just pick that as 1. I13 is that blue line, right, on this circle diagram. We have to find a triangle, 2 triangles that share that vertice. And because we just found I14, we actually do have one right now. So we can use what triangles? We can use this one, the one for I12, I23, that shares this vertice, and then we also can do 3, 4, and 1, 4, right? And it has this in there as well. So let's draw those lines. So what we can do is, let's do I12 and I12 and I23. So I12 is here, right? And I23 is here. So we must draw a line through that, which I'm going to do my best. So something like that, right? Line straight through it. That is one side of the coin. Now we have to do the next one. The next side of the coin is, we must do I14 and I34. So I14 is right here. I14 and I34, which is right here, right? So right here, this is a perfect case for another thing I have to explain to you. So right here, it might look like these things are parallel, right? Just based on how you draw them, and it might look like they'll never connect. And sometimes they might not. But if they go this far off your paper, what you're supposed to do is, there's like a certain notation. I'm fairly certain it's like you write plus or minus infinity. I'm gonna make sure of that before we keep going. Yeah, so that is the notation. So basically what it is from here, you say that I13, so what you would do is, if these two look like, so you could just do this. You would say that I13 is along this line at plus or minus infinity. And it's along these lines. Essentially, it is somewhere on these lines when they do connect at some time towards infinity, right? This is the notation that you would write for that. Because I know there are some questions where, however, this one will be a little more angled in, and they will connect, but it will connect off your paper, so you have to like add a little tiny piece of paper and then keep drawing it. This one right here, though, they look to be almost parallel, if not parallel, although I don't think they are. I just think they're very close to the same angle. So you just write this. So that is where I13 is, and I'm going to darken in the line every time we find it, so I'll get rid of that. So I'm going to remove this. I'm going to remove every single one of them as we do it, though, because it's going to get to be a mess. And so this video is going to be up there, so you guys can go back and like just pause it for every one of them. But yeah, it gets to be a big mess. All right. So now let's do another one. So we have, what else can we do? Any other thoughts? Which other ones can we do now? Two, 5. So you say 2, 5, which is here. So I will mark that in with a little dashed line. So what triangles are you going to use for 2, 5? Can we do 2, 5 yet? You say 6, 4. Six, 4. So 6, 4 is this right here. So 6, 4 right there. So we have one pair right here, which is we have 6, 5 and 4, 5. And then I'm assuming you guys are going to use 1, 4 and 6, 1. Is that correct? Yes. So now let me get that color back if I don't already have it. So from here, we go to I16, which is right here. So I'm going to draw this line. We know it's there somewhere, right? But remember that rule I said that for sliders we move it to the one that you're messing with. And so what we're messing with is I16 and I4. Oh, I went backwards. Never mind. We'll do the other one first because that one will probably make some more sense. So I65, which is here, connected with I45, which is here, right? So it's straight along that very wobbly line that so it is along this line. I64 is along this line, but we need to find another one to be able to pinpoint its exact location. So we use this one, which is I16 and I14. So remember, I14 is up here, right? And the rule of that slider thing I told you about was that we take the slider, like plus or minus 1, and we move it all the way up to the other pair. So we would take this line, so that is here, and you move it all the way up to here. And when you do that, and you extend this line out far enough, you end up with something like that. I know it's not drawn perfectly, but you get the point though. I64. An I35. There should be an I35. That's another one I forgot. So thank you. you are correct. Essentially, I forgot to do this pair as well. So 3 and 5, 3, 5. So 4, 3, 3, 5, and 4, 5 all exist here as well. So this is another thing that this is something that I struggle with in the class and clearly still do. That I sometimes didn't know what I already had. And so I would be like fumbling around trying. Basically, let's put it this way: if there's one thing that is on the paper that you already have without having to pinpoint it, and you're trying to find everything else, you'll come to a point where you will not be able to find anything else, simply because you don't have enough triangles, right? So you said I35, which you are correct. There is one that goes over here. You are right. And then I64 we have found right there. Although obviously it's like down here somewhere because I drew it really poorly. But I'll actually try that a little bit better. Let's see. Anyway, so it's right there. So that right there is I 6, 5, or I 6, 4. So I 6, 4 is right there. Now, you guys are probably all wondering, man, like how many of these do we have to do? So, the good news is you don't have to do all of them. The question generally asks you for something like this. They'll go using the instant center method, find the kinematic coefficients for link 3 and link 4, which would be H3 and H4, right? And because you guys know what the equation is, this is we'll just do H3 is equal to I 1, 2, I 2, 3 divided by I 1, 3, I 2, 3. I think that's what it was. But essentially, if you look right here on the page, these are the only instant centers you need to know for finding H3. Would you agree? And then similarly for H4, it would just be everything with a 3, you plug in a 4 there. So actually, if it asks you for a specific link's or kinematic coefficient, like these two, H3 and 4, you don't need to find all the oddball ones. Like for example, if you needed to find H3 for this question, you would not need to find, say, 6, 5, right? Or 1, 4 or something like that. Or 3, 6 or 3, 5. Like these are things you don't need to know because they don't come into a play in this equation. But if they ask you to find every instant center, then you should find every instant center. But for something like this, which has quite a bit of instant centers, I probably wouldn't ask you for all of them. I would just ask you for something like this, H3 or H4, which means you only need to find these. Does that make sense? Alright, so I'm going to get rid of this one now as well. Clear it off a bit. So now that Jackson has gotten us this one, and we now have this one and all this, we're starting to fill this in, right? We're starting to get closer to where we can do the next part, right? So, or we can do another instant center. So anybody want to take a shot at which ones do we have left? That's a good question. Which ones do we have left? So I'm going to make them down here. So we have I 3, 6, it looks like. I 1, 5. Should be here. 2, 3, 4, 5. Yep, that one's the only one. Now if you go to 2, we have I 2, 5. Should be there. I 2, 4. Here. I 2, 6. And 3. I 3, 6 I already have. 3, 4, 3, 5, so that's good. 4, 5, so I 4, 2, which I already have here. I 4, 1, I already have. This one. Yeah, so I think that's it. So these are the ones we're missing, I think. If you have another one, let me know, but because this thing's kind of jumbled, but these are the ones that we're missing. So if I were to ask you to find H4, you would need to find this. All the rest of these are irrelevant. This is the only one that you would need to find if you had to find H3 and H4, this is the only one you would actually need to find. So basically what I'm telling you is that you don't need to find all of them if the question doesn't ask you to find all of them. But if you guys want to go through and find, how about this? Let's find like 3 more. Let's find 3 more, and then we'll find this one first, and then we'll find some other ones, and then we'll call it. Because obviously this question is in the book. You can find all of them, so actually not just in the book, it's right here. So as you can see, there's a lot of jumbling mess here. So anyway, and I don't want to really have to draw all that. So we're going to try let's do this color. So we're gonna do I24. So I24, which is right here. So I24, can we find I24 as of now? Anybody have some triangles we can use? Because it looks like we can. What I would suggest using is, or what I would just, my first thought was 2, 3, 3, 4, and then 1, 2, and 1, 4. So you're using this triangle and this triangle. So let me go ahead and remove those, and then we will go ahead and find it. So let's start with I12 and I14. So I12 is right here. I12 and I14. I14, which is here. Okay, is this going to be another one of those ones that doesn't equal up? Oh, no, that wasn't the one. It was another. It was like this. It was the 2, 3 one in that. So I12, which is at this location right here, and I14, which is right here. So the line looks something like that. Right? And then, so that takes care of one triangle. Then the other one is I23 and I34. So I23 is right here, and I34, which is right here, right? So if you connect those lines, that is where I24 must be located. Does everybody see how that worked out? And why it's there? Essentially, we used this triangle. Here, I'll make that a little bit bigger, but we used this triangle, and we used this triangle, and used those instant centers and found it. So now that that one is good, I'm going to fill it in. So we have found that one as well. So that one is been marked off. Another one bites the dust. So now let's find 2 more, as I said. So let's find, I don't know. You guys want to try 1, 5? So 1, 5 would be here. And could you do another one with 1, 5? Yes, it appears that you could. So let me find another color. Let's do orange. So we're looking for this right here. So 1, 5 is this one. So very obviously one of them is 1, 6 and 6, 5, right? Pretty clearly those are 2 ones that you could select as one of your triangles. The other one you could select would be 1, 3, 3, 5, and 1, 5, right? So this big triangle versus this tiny one. And since you said 2, 6, Muhammad, we'll do that one next. So let me go ahead and remove these. So once again, let's go out there onto the page. Let me erase this. Alright, so I61, which is once again this line right here. So I'm not going to draw this one yet. And I65. So I65 is right here. So this one actually makes, this one's actually pretty easy for us, is that you just move that line of the translation to where this connects, which is I65. So that one actually worked out really easy. You just move it to this point. So that's where one of the line exists. Now we have to find the other one, which is 1, 3 and 3, 5. So 1, 3 is 1, 3. And remember where 1, 3 is? I'll find it. I have the other one open on the other page. 1, 3 was. Oh, did we not? Oh yeah, 1, 3 was located along those lines at plus or minus infinity. Ah, okay. So essentially 1, 3 was this one where it was like, you know, going down the page like that. So let me see actually how they handled that one. I'm actually curious how they did it. So they used 1, 4. Let's see, 1, 4, and 4, 5. Oh, okay. So they did this one. So this one actually leads me to another thing I should probably talk about. Is that if you do these a certain way, because this one, that remember how we found 1, 3 earlier, that it was plus or minus infinity way down this, like down the page. That one doesn't get you an exact solution for other ones, so try to avoid using that one, and I did because I didn't see the other triangles because this is really jumbled. But there's another triangle in here you can use as well. You can use 1, 4, and 4, 5, right? And you'd get this. So if you do 1, 4, and 4, 5, and still use 1, 6, and 6, 5, you will get 1, 4, which is right here, and 4, 5, which is right here. And if you draw a line straight through it, you end up with it right here, instead of where it would have been before, which we wouldn't have been able to pinpoint its exact location because of how the other one was. So basically, if you get one that's like plus or minus infinity, if you get an instant center that's plus or minus infinity in some direction, try not to use that one for a solution. And I think the way that he does it, or how he teaches it, is that he makes he tries to avoid using those for solutions because it doesn't pinpoint anything very helpful. And so I'm gonna fill that in as well, and then mark that off as I-15. So I-15 gone. Now we're going to do the one that Muhammad said, which is 2, 6. So we're going to work with 2, 6. Let me get another color really fast. Let's do green. So 2, 6. So this is the one we're working with. So I-2, 6. So Muhammad, since you said that, you can tell us which pairs that you would use. So 2, 6 is here. It is this line. One, 6, 1, 2. I agree. So he used this one and this one. What is the other triangle you're going to use here? You probably have a couple of choices. But which one are you going to use? What other triangle? 1, 3, which is... be careful, though, about using 1, 3. But I don't know how you would use 1, 3 here. Oh, you're talking about... We don't have 3, 6, so we can't use that 1, 3. What about 2, 4, and 6, 4, or 4, 6? Yeah, so 2, 4, and 4, 6. So essentially the two triangles we are going to use are, and then here, here, and here. So if we do that, we will arrive at the following. So 1, 2, and let's do 1, 2, and 6, 1. So 1, 2 is right here. 1, 2 is right there. And 6, 1 is right here. And remember, what we do is we take this plus or minus infinity, slider, and we move it up to here. So our line goes right across that point. And real quick, before we move on, I would like to get a hand in the chat for how straight that line is. Anybody? It's a pretty good line, is it not? Dude, you are fast with these GIFs. So, really good line. So, right here, this right here is I-12 and I-16 connected. Because we took this right here, this line, which is the sliding one, and you move it up to the pair that it's working with, which is up here at I-12. Now we have to do I-24 and I-64. So I24, which is where did we put that one? Anybody remember? I think it was right here, right? If anybody recalls, yeah, I'm right. It was right there. So I24 was right here. It was that one that we like connected in the middle here. It was that crossing one that ended up right here. So I24 is right here. If I had the line tool, I would leave it all up and it would look really nice, but I do not. I keep saying I'm gonna spring for the line tool, but I haven't yet. I apologize. So I24, which is here, and then I64. Where did we find 6-4, I wonder? Does anybody remember where we found 6-4? I mean, I can find it. If not, it's not a big deal. Oh, yeah, now I got it. 6-4 was way over here. Remember, it was that line that I said, I'm going to draw this better, and I didn't really. Yeah, good times. You were there, I was there. So, then what you do is you connect these two lines, I24 and I64. So that is something like that. And you end up right here, which is which one was this one? 6-2? I62. Or 2-6. It doesn't really matter, but right there. And real quick, as I marked these down, this one right here once again was this one's I24 and this one was I64. Yeah, 6-4. I64. So we basically almost got all of them. The last two are just I25 and I36, and you would do this one just like the other one. So I36 is right here, and you would just make two triangles out of it. Now that we know where 6-2 is, 3-6 becomes easier because we can now make a triangle there using this one, and then you can make one using this right here. Or 3-6 is right here. So let me see actually how you would do that one. So if you did this right here, you could use this triangle as one, and then you could use 4-6 and 3-4. So, but just before we get out of here and take attendance, what I'm going to do is I'm going to show you the very neat solution, which is on the next page. You got a little glimpse of it during this, but the very neat solution is obviously one done with a line tool and a lot of time and effort. So, I forgot to do any more steps. So step 2, this is not a very long question, or long steps. Essentially, it's step 2 is do the instant centers that you know. And what I mean by that is that the instant centers you know are the ones that you can find just by looking at it. So for example, revolutes like this, and sliders like this one. And as I showed earlier, and as Jackson pointed out, is that it's quite easy to miss ones if you don't do it in a nice fashion, like a very organized fashion. It's very easy to miss them. And then 3, you fill out the circle by using triangles. I'll just put a triangle there, although I don't know if that's smart. Never mind. Triangles. Yeah, there's not a big process for these. Essentially, you just write the circle diagram, you do the ones you know, and then you find out the other ones. That's basically it. There's not much more to it, I'm afraid. But if you go through it slowly and you just do what we did by finding your triangles and using a better tool than the one that I have, which is this marker, it'll be really easy. And I know a lot of people that did this. They used colored pencils or something, and they just made lines different colors like I did. So, for example, there's a girl last semester who used color. She printed it out and used colored pencils, and her paper was immaculate. Like, everything was color coded down to the. It was great. It was 100%. 100%. So you don't have to go that deep, right? But what you should use is, please use a ruler. Do not try and freehand it like I do. Although, once again, my lines aren't too terrible, but they're not that great either. So, all right. So this right here, whenever I move down, will be the neat solution, and then you guys are free to go. I will take the attendance in a second. All right. So this right here is the neat solution, and it comes out to where everything that we did was exactly in the right spot. So if you recall, 4-6 was up here. 2-4 was that one that was on this line here. 2-6, which is the last one that we did, is over here, which, remember, if you recall, we moved this line up to here, and then we connected it with 4-6, which ends up right here. I-15, if you recall, once again, down here. And then now here's the other one. So we didn't do 3-6, but 3-6 ends up where they use I-2-6 and I-2-3 and I-5-6 and I-3-4 or I-3-5, whichever one they did. And what ends up happening is that these two are also on near parallel lines. So this is another one of those solutions like I-13. And these two are very similar, that you would just write them at I-36 at plus or minus infinity along those lines. So basically we got all of ours right, it looks like. Although, once again, we did not do, there was one that we didn't do, right? Which other ones didn't we do? We didn't do what, 2-5 and 3-6? Was that it? I think there's the only two we didn't do. So, and I-25 you would find to be way up here, using the same method you did before. So, yeah, those are the last two we didn't do. But if you need to look at this a little more, they did it in steps. So right here, you can actually see that they had the blank circle here of all the ones they know. And then they filled it out using these colors. So I-31 was the first one. And they just moved along the path here. So, and with that, I'm going to go ahead and stop the old stream, and we will take attendance.